Today we're going to be working with quadratic functions that are in intercept form instead of standard form, and we're going to focus on finding the zeros of the function, the vertex, and the axis of symmetry. So the one thing to notice on this is we're no longer working in standard form. Now our standard form, if you can remember, is the y equals ax squared plus bx plus c. That's called our standard form. But if you notice, when we're looking at today's practice, none of these guys are in standard form. So the question is, does it matter if it's in standard form or not if we're using the calculator? The answer to that is no. The reason they have these other forms is because they're actually kind of convenient to give you information. You don't have to understand or remember what information they give you, but if you do, it makes it convenient and a little bit faster to solve problems. So let's start with number 1. And what we want to find are our zeros, or our x-intercepts. They're the same thing. And we also want to find the axis of symmetry. So go ahead and make this big. First thing we're going to do is just go ahead and put this into the calculator. So put the y equals button, put this equation exactly as it is with parentheses into the y equals, and then press graph. Now when you do this, you can see that it's crossing the x-axis 2 different times. So we know that we have 2 solutions, and you can just kind of use your pencil and count over and see that it looks to me like one of them is x equals -2, and the other one looks to be x equals 4. Now we can go into our table and just verify that these are really the zeros of the function. So press second and table and scroll up to the -2, and when you see that x equals -2, you'll notice that the y value is 0. And scrolling down where x equals 4, the y value is 0. So you know you have found your 2 solutions to this particular equation. Now, we need to find the axis of symmetry. You've got a couple of ways that you can go about finding the axis of symmetry. One way is to find the vertex, and when you find the vertex, you know that the axis of symmetry is the x value. So I'm going to one option is find the vertex and get x equals. The other option that you have is to understand the symmetry and the zeros, because our axis of symmetry is the thing that cuts your zeros directly in half. So if we look at our graph, I'm just going to sketch kind of a sad little graph here for you to look at. We've got -2 and +4. So our zeros are here at -2 and at +4. Now if you think about the function of an axis of symmetry, it has to be exactly in between these 2 points. It has to cut it symmetrically. So if we look at our 2 points, we can just say we go over 1, 2, 3. That kind of looks like it's in the middle. And then let's do it from this side. 1, 2, 3. Okay, so 1 is exactly in the middle. So without even finding the vertex, I can draw my axis of symmetry and know that it's x equals 1. So you've got a couple of options. You can use what we've learned in other classes on using the calculator to find the vertex, and I know that's very fast and simple, and then just use the x value of the vertex. Or you can just look at your 2 zeros and using those as your symmetrical points, find the point that's exactly in the middle, and that's going to be your x equals for your axis of symmetry. So those are the 2 options that you have on it. The rest of these practice, go ahead and put them into your calculator. Same thing, find your two zeros, verify in the table that those are the two zeros, and then either find the vertex to get your axis of symmetry or just come to the middle to get your axis of symmetry. Okay, so let's look on down at the bottom of the page and just make sure that we can do all the things here. So on number 5, we want to graph x plus 5, parentheses x plus 1. So when I put that into my calculator and I graph it, I can look and see that my x values are x equals -5 and x equals -1. Question, do you see any relationship between my two roots or my two solutions and my original equation in the intercept form? And what I'd ask you to pay particular attention to is this +5, -5, +1, -1. That's the whole point of the intercept form, is when it's in this format, the number in the parentheses with the x is your intercept. So we've got, it's just the opposite. So if it is x plus 5, that +5, if you take the opposite, -5, that's one of your solutions. And the +1, -1 is one of your solutions. Now there's a caveat to this. If it had been like 3x plus 5 or 2x plus 1, then that doesn't work exactly that way. But if you just have a plain old x plus a number or minus a number, then this is a quick, dirty way to get your intercepts or to get your solutions. Okay, so I'm going to go ahead and graph this, and I've got -5, which is 1, 2, 3, about right, oops, 1, 2, 3, 4, 5, about right here. And I've got -1. And then if I want to get my axis of symmetry, it's going to go right here at the -3. That's going to be directly in between my 2 points, so x equals -3. And then I'm going to use my calculator to come up with my vertex. And when I look at my calculator, I'm actually just going to look at the table to see my vertex, because I know that the x value of my vertex is -3. So I can look at the table and see that I've got -3, -4 is my vertex. So kind of about right here, and I'm going to sketch it. Okay, so I've got my x-intercepts. That was the x equals -5 and the x equals -1. Domain and range is the main reason I wanted to go over this with you. Domain on a parabola, on our quadratics, domain is always all real numbers. Because domain is read, Dolar the robot, left to right, and we cannot put a boundary on either our left or our right side because of these arrows. Now to find out our range we're actually going to be using the y value, because range is y, of our vertex. And if we go down to where our vertex is, I'm going to just put my pencil on the vertex. Now, is my graph above my pencil dot or below my pencil dot? Well, it's above my pencil dot. So I know that my range is greater than, it's above. So my range is going to be y is greater than or equal to the -4, the y value of my vertex. Okay, so now let's turn. And if we look at practice number 9, what practice number 9 has given us is an equation that is not in our standard form, but it wants us to write it in standard form. So think about what the calculator gives us. The calculator, when we use stat edit, will give us equations in our standard form. So what we're going to do is just put this equation into the y equals key of our calculator and get a couple of numbers from our table. So when I put it in and I pull up my table, I'm just going to write a quick 3 points from my table. I need 3 points in order for StatEdit to give me a quadratic. So I've got 0, 8, 1, 15, and 2, 24. So now that I've got 3 points, I'm going to use these 3 points, put them into StatEdit, and get my equation. Then when I do my stat calculate, I'm going to do stat calculate 5, because 5 is for quadratic, and we are working with quadratic equations. So my equation is y equals 1x squared, so I'm not going to write the 1, plus 6x plus 8. So the big part about this is just getting you to start thinking about how much your calculator can do for you. If you can get something into y equals, you can always pull up points on the table. If you've got points on a table, you can use StatEdit and always get your standard form. How do I check to see if I've done this correctly? I would put, using my calculator, I would put the original equation in y1, my answer in y2, and pull up my tables. If my tables matched exactly, then I know I have the right answer. So just keeping you thinking about how does your calculator help you? In what ways does your calculator help you? Okay, so now let's look real quick at number 11. Just make sure you understand on number 11. So number 11 has given us our x-intercepts. So I'm going to draw a quick little graph, and I'm going to say, okay, my x-intercepts are at -4 and at +7. Okay, so once we've got the -4 and the +7, we can write our equation. X, the opposite, so x plus 4, x minus 7. That's going to be my equation, but it's asking for it in standard form. So what I'm going to do is I'm going to put this equation, based on my intercepts, into the y equals of my calculator, and I'm going to write down one more point, because I already know I've got 1 point at -4, 0, a second point at 7, 0. So put this into y equals, get my third point, go through the StatEdit process, and write it in standard format. Okay, so that's all really for the lesson. If you have any other questions, feel free to come in during tutorials.